In this video, we'll talk about why every new needs a delete and every new array needs a delete array. So we'll use the same code we used in the previous video where we created a class and we created a public constructor and a destructor. And we've got the main. In the main, we created an object on the stack. That for that object, when the main ends or the object goes out of scope, the destructor will run automatically. However, when we created an object on the heap, for that object we need to manually free it by calling delete. And if we don't, the destructor will never run, and that will cause memory leak. Just a summary on what we did on the stack. C++ takes care of cleanup for you. However, on the heap, it is your job to call delete. So if you notice, just to sort of get into the topic of today, we created the object using new. We use delete to delete it. So heads up, when you create one object, not an array, you use delete. But if you create a new array, you need to use a delete array. So let's demonstrate that using the guided comments. In the first comment, we want to declare a private pointer. Private pointer member that stores the address of dynamically allocated memory, accessible only within the class. So it's private. So what this private means, this variable, let's actually create it. It's an array, an integer, a pointer. We'll call it data. So this means that the variable data can only be accessed from inside the class, but not from main or anywhere outside the class. So yeah, so this pointer, it points to an integer and it will hold the address of the memory address we dynamically allocated. Let's go into the second note, second to do, which to dynamically allocate an array of 5 integers on the heap using new. So the minute you use the keyword new, that's going to be sitting on the heap. Okay. And let's move to our third to do, which is pretty much working in the constructor. Oh, sorry, let's just talk a little bit about what I've done here. So C++ allocates memory for 5 integer values, and it returns the address of the first element of the array. That address is stored in the data pointer, which is of type integer. Now this memory will stay allocated until we manually free it, and we will free it in the destructor. The destructor is a special function that gets called when an object is destroyed. If you're on the stack, this happens automatically. Like we saw down here, when we created this object on the stack, we didn't have to call the destructor manually. However, if you're on the heap, then it happens when you call delete. That's why we actually had to call delete the heap object. So that's what we want to do here. And this the third to do is free the array using delete array. So basically we'll just delete the array and the name of the variable data. So here notice that I've actually used delete with square brackets instead of just delete. And that's because we used new with square brackets as we created an array basically. So to properly deallocate the entire array, you need to delete the whole array. So when you use new for a single object, you use delete. And when you use new, like for an array, you want to use delete array. Don't mix and match because doing so will cause you a problem. What I mean by mix and match, if you create new, like say new array, and then you only do delete by itself, that's not correct. So you need to pair it with a delete array like we did here. So new array, delete array. All right, let's have a look at what happens here. So let's just build and run. Okay, so let's have a look at what we are getting. So the constructor is called for the object created on the stack, and then again it's called for the object created on this on the heap. Then we call delete heap object, so that's going to call manually call the destructor for the destroying this object. And then once the main has ended or the object went out of scope, in this case it was up to this line, that's when the destructor was automatically called for the stack. So on the stack, it's not a problem. You don't need to call delete. However, on the heap, if you forget delete, the destructor never runs, and that means memory will be lost, and that's a memory leak. But just so to confirm when each one was called by who, because we are getting the same message every time. So we know that we know the order because we understand how things happen, but let's confirm that by actually passing a string to let us know which constructor called which. Was it the one on the stack or the one on the heap? So I'm going to create another variable called instance variable called location, and I'm going to be passing to the constructor a string, and let's call it source. Now, inside the constructor, I'm going to assign the value sitting in source to the variable location. And then over here, I'm just going to add some extra code to send out the location. Basically, we just want to know which constructor is called, which object has made the call. So that's one thing. And for the destructor, again, we also want to just sort of probably, yeah, memory deallocated. That should be all right. And then what we're going to do is when we created this object, we'll pass the string stack. We just want to basically pass that label to the constructor. And then when we created the one on the heap, we just want to pass heap. So this will give us more clarity when we call the just build again. Just make sure there are no errors and run it one more time. And so this gives us the order of who made the call first. So initially the constructor was called for the object on the stack, and then it was called again for the object that is sitting on the heap. So that's looking good. Then because we called delete, manually deleted the object on the heap, so that called the destructor passing heap for the heap. And then when the main has ended, so that the object on the stack is no longer needed, and automatically the destructor was called for the stack. So we never had to call it for the stack. So that was just extra confirmation for us. So the best, what we take from this video is that every new should have a delete. Every time you create an object, you want to have a delete. That new means it's sitting on the heap. Every new array as well should also have a delete array. So don't forget the square brackets. When you have square brackets for new, you need to pair them with square brackets for delete. Never mix new with delete array or new array with delete. I hope this makes sense, but that pretty much sums up our video. Thank you so much for watching, and I'll see you in the next one.